Hey there, curious minds. Today we're tackling something that'll make your architecture professor spontaneously combust. The idea that humanity's most magnificent buildings weren't constructed from the ground up, but installed from the sky down. Yeah, you heard that right. Those grand cathedrals, exhibition halls, and city monuments everyone assumes took decades of scaffolding and sweat? Plot twist. They might have been delivered via massive airships and precision dropped into place, like the world's most elaborate IKEA furniture. We're talking about atmospheric engineering, a lost branch of technology where 19th century dirigibles weren't inventions at all, but the last functioning remnants of an ancient transportation grid. Wild, right? So here's the question that should keep you up at night. Why would a civilization that mastered the art of hovering multi-ton structures in midair with millimeter precision suddenly abandon that knowledge and go back to hauling bricks up ladders? What happened to cause this massive case of technological amnesia? Before we dive into the rabbit hole of lost airship technology, crystalline domes, and underground energy networks, do me a favor. Smash that like button if you're ready for your mind to get thoroughly blown, and drop a comment telling me what corner of the world you're watching from. Seriously, I want to know where my fellow reality questioners are hanging out. Because what we're about to explore isn't just about old buildings and fancy ships. It's about rewriting everything you thought you knew about human capability, historical timelines, and why certain technologies conveniently disappeared right when they mattered most. Buckle up, because this journey goes way deeper than you think. Let's get into it. Now let's talk about the actual airships themselves. Because calling them dirigibles is like calling a Tesla a fancy horse carriage. Technically, they both get you from point A to point B, but you're missing about 90% of what makes them work. When you look at photographs from the late 1800s and early 1900s, you'll see these massive vessels floating over cities, and the official story goes something like this. Oh yeah, those are just hydrogen balloons with some propellers stuck on them. Nothing to see here, folks. Except here's the problem. Everything about these craft screams that they're operating on completely different principles than what we're told. And I mean everything. First off, let's address the elephant in the room. Or rather, the airship hovering perfectly still over the room for 6 hours straight. Modern blimps and dirigibles can't do that. They drift, they bob, they need constant adjustment to maintain position. Wind hits them, air currents mess with them, and their pilots are constantly fighting to keep them where they want them. It's like trying to park a beach ball in a windstorm. Technically possible, but requiring constant effort and correction. Yet in photograph after photograph from the late 19th century, we see these massive atmospheric vessels holding position over construction sites with the kind of precision that would make a modern drone operator weep with envy. No visible propellers spinning frantically to compensate for wind. No obvious thruster systems firing to maintain stability. Just perfectly still, hovering like someone hit the pause button on reality itself. The standard explanation for this is laughably inadequate. Oh, they had really good pilots and favorable wind conditions. Right. Because apparently every single day in every single city across multiple continents had absolutely perfect weather conditions with zero wind whenever these airships needed to hover for construction work. What are the odds? About the same as winning the lottery while being struck by lightning on your birthday. Twice. The far more logical explanation is that these vessels weren't fighting against atmospheric conditions at all. They were controlling them. Let's talk about the actual construction of these ships, because this is where things get genuinely weird. The hulls weren't made from canvas or rubber-coated fabric like the dirigibles that came later. They were sheathed in copper. Thick, precisely fitted copper plates that covered the entire exterior surface. Now, the official explanation for this, when anyone bothers to provide one, is that copper looked nice and prevented corrosion. Because naturally, when you're trying to build the lightest possible flying machine, your first thought is, let's cover it in one of the densest metals available. That makes perfect sense if you failed physics and have never actually thought about it for more than 3 seconds. But here's what copper does that canvas doesn't. It conducts electricity. Really well. In fact, copper is one of the best electrical conductors we know of, which is why we use it in basically every electrical system on the planet. So why would you need an electrically conductive hull on an airship unless that airship was doing something electrical? And before you say lightning protection, let me stop you right there, because that's not how lightning protection works on aircraft. Modern planes use aluminum, which is lighter and cheaper, and they're designed to let lightning pass through them, not interact with it in some complex way. But these copper-plated atmospheric vessels weren't trying to avoid electrical interaction. They were designed for it. Inside these copper shells, contemporary descriptions mention something absolutely fascinating. Chambers filled with what witnesses called crystalline structures, or glass-like formations. Now, if you've been paying attention to anything related to early electrical experimentation, you'll know that quartz crystals have some pretty remarkable properties. They're piezoelectric, meaning they generate electrical charges when subjected to mechanical stress, and they can convert electrical energy into precise mechanical vibrations. Tesla was obsessed with crystals for exactly these reasons. So finding quartz chambers inside copper-hulled airships that could hover motionless for hours? That's not a coincidence. That's a design feature. The geometry of these vessels was also extremely specific. And we're not talking about, let's make it cigar-shaped because that's aerodynamic. We're talking about precise mathematical ratios in the proportions of the hull, length to diameter ratios that show up again and again across different vessels. Almost like someone was following a blueprint that had to be exact for the system to work. Modern aerodynamics would tell you there's a lot of wiggle room in airship design. As long as you've got a roughly streamlined shape, you're good to go. But these atmospheric vessels showed almost no variation in their fundamental proportions. It's like every iPhone being exactly the same dimensions because that's what the technology requires, not because Apple lacks imagination. Here's where it gets really interesting, though. These ships didn't just hover. They could apparently manipulate their own weight. Multiple eyewitness accounts describe seeing these vessels lower massive architectural elements with a smoothness and control that shouldn't be possible if you're just playing with ballast and gas bags. We're talking about multi-ton copper domes, stone columns, entire prefabricated sections of buildings being lowered into place with millimeter precision. Try doing that with a hydrogen balloon and some rope, and you'll understand why this explanation falls apart faster than a chocolate teapot in a sauna. The propulsion system, or rather the lack of an obvious one, is another massive red flag that something else is going on. Sure, some of these vessels had what looked like propellers, but they were pathetically small compared to what would actually be needed to move these massive structures. It's like putting a desk fan on a cruise ship and expecting it to cross the Atlantic. The math doesn't math, as the kids say. And yet these airships moved. They traveled between cities, crossed mountain ranges, navigated to precise locations, and held station in conditions that would send a modern blimp running for the nearest hangar like a scared puppy. What we're looking at here is technology that manipulated atmospheric density itself. Think about it. If you could locally decrease the density of air around your vessel, you'd effectively be creating a bubble of lighter atmosphere that would naturally rise. Control that bubble precisely, and you could hover, move, ascend, or descend at will. You wouldn't need massive gas bags because you wouldn't be displacing air the normal way. You'd be altering the air's properties directly. It's the difference between floating on water and controlling the water itself to push you up. One requires massive buoyancy. The other requires understanding how to modify the medium you're operating in. The copper hull would act as both a containment field for this effect and a conductor for whatever electrical process was driving it. The quartz chambers would generate or modulate the electrical frequencies needed to create this atmospheric modification. The specific geometry would ensure the field was stable and evenly distributed, and the result would be a vessel that could do things that look like magic to anyone who doesn't understand the underlying physics. Which, conveniently, includes pretty much everyone today, because this knowledge was systematically scrubbed from the historical record. Now, you might be thinking, okay, but if this technology was so amazing, why don't we have it now? Great question. It's the same question you'd ask about why we can't build the pyramids with the same precision as the ancient Egyptians, or why Roman concrete is still superior to modern formulations in certain ways. Sometimes civilizations lose knowledge, either through catastrophe, deliberate suppression, or simple neglect over generations. In this case, though, there's evidence suggesting the loss wasn't entirely accidental. When you look at how systematically this information disappeared from technical manuals, how photographs were edited to remove these vessels, how patent applications related to atmospheric density manipulation mysteriously vanished or were classified, it starts looking less like historical amnesia and more like historical cover-up. The last of these atmospheric vessels seem to have been operational until around 1910 to 1915, after which they suddenly vanish from the photographic record. The official story is that dirigibles and early airplanes made them obsolete, which is like saying that smartphones made rotary phones obsolete. Except in this case, the smartphones are objectively worse at what the rotary phones did. Early dirigibles were death traps that exploded if you looked at them wrong. The Hindenburg disaster in 1937 was just the most famous example of hydrogen-filled airships being fundamentally terrible ideas. Yet somehow, these earlier atmospheric vessels operated for decades without any similar catastrophic failures. Almost like they weren't using explosive gases at all. Funny that. What's even more telling is how the construction techniques changed after these vessels disappeared. Suddenly, we're back to cranes, scaffolding, and armies of workers manually assembling buildings piece by piece in a process that takes years instead of months. Major architectural projects that were completed in remarkably short timeframes in the 1880s and 1890s suddenly required double or triple the construction time in the 1920s and 1930s, despite supposedly better technology. It's a regression disguised as progress, and nobody in official academic circles wants to touch this discrepancy with a 10-foot pole. The technical manuals and engineering documents from the late 1800s are another fascinating dead end. You can find incredibly detailed technical drawings for steam engines, factory machinery, bridges, locomotives, basically every other piece of Victorian-era technology. But for these atmospheric vessels, crickets. A few basic sketches that look like they were drawn by someone who'd never actually seen the real thing. No detailed blueprints, no engineering specifications, no maintenance manuals. For vessels that were supposedly commercially operated across multiple countries for decades, this absence of documentation is absolutely bizarre. It's like if 50 years from now, all the technical documentation for Boeing 747s had mysteriously vanished, leaving only some napkin sketches and tourist photos. The people who operated these vessels also disappeared from the historical record in interesting ways. Pilots and engineers who were prominently featured in newspaper articles in the 1890s are virtually impossible to find any information about after 1915. Their names appear in city directories, then suddenly stop. Their obituaries are strangely brief or missing entirely. It's like an entire profession just evaporated, taking its knowledge with it. And before you say, well, they probably just retired, ask yourself, when was the last time an entire industry full of highly skilled specialists just vanished without training a single successor or leaving any institutional knowledge behind? That's not how technology transfer works, unless someone really doesn't want that transfer to happen. Contemporary skeptics and mainstream historians will tell you that these vessels were just early dirigibles, and that any unusual capabilities are either exaggerated witness accounts or photographic artifacts. To which I say, look at the photographs yourself. Not the carefully curated ones in history textbooks, but the ones in local archives, family collections, city planning documents. Look at vessels hovering perfectly level while lowering architectural elements. Look at the hull construction that's clearly metallic, not fabric. Look at the absence of massive gas bags that would be necessary for conventional buoyancy. Look at the precision of placement in construction photographs. Then ask yourself, does the official explanation actually explain what you're seeing? Or is it just a convenient story designed to make you stop asking questions? The atmospheric vessel technology wasn't primitive. It was advanced in ways we still don't fully understand. It represented a completely different approach to manipulating physical forces, one based on understanding and controlling atmospheric properties rather than brute forcing through them with combustion and mechanical thrust. And that's exactly the kind of technology that threatens existing power structures. Free energy from atmospheric electricity, transportation that doesn't require fossil fuels, construction methods that don't need massive industrial infrastructure. These aren't the kind of capabilities that oil companies, utility monopolies, and industrial giants want competing with their business models. So what happens when such technology exists? History suggests it gets quietly disappeared, and new generations are taught that it never existed in the first place. Which brings us to the next piece of this puzzle. Because these atmospheric vessels weren't just floating around for fun, they were part of a much larger system, one that connected architecture, energy, and transportation into a unified network that spanned continents. But to understand that system, we need to look at what these vessels were actually doing, and more importantly, what they were installing. So what exactly were these atmospheric vessels installing with such obsessive precision? Glad you asked, because this is where things get properly mind-bending. Those gorgeous cathedrals, ornate city halls, and elaborate exhibition pavilions that we assume were built as fancy places for people to worship, govern, and show off their industrial achievements? Yeah, not so much. Or at least, that wasn't their primary function. These structures were nodes in a planetary energy grid, basically giant machines disguised as architecture. And before you roll your eyes and click away, stick with me here, because the evidence for this is hiding in plain sight all over these buildings. Let's start with something simple that everyone can see: spires. Every major building from this era has them, and the standard explanation is that they're decorative or symbolic, reaching toward heaven, making the building look impressive, whatever. But here's a fun question. Why are they always made of metal? Specifically, why are they copper or bronze, often with gold leaf on top? These are expensive, electrically conductive materials being placed at the highest point of the structure. If you were just trying to make something look pretty, stone would work fine and cost way less. But if you were trying to build an antenna, and I mean a serious, functional antenna for capturing atmospheric electrical charges, then putting a tall metal conductor at your highest elevation makes perfect sense. In fact, it's exactly what you do. And these weren't just any metal spires stuck on top haphazardly. They were geometrically precise, with specific ratios of height to base diameter, specific numbers of facets, specific angles. Look at a dozen different cathedrals from this period, and you'll notice the spires follow remarkably similar mathematical principles. That's not artistic preference, that's engineering specification. It's the difference between someone randomly doodling a tower and someone calculating resonant frequencies. One looks nice, the other actually does something. But spires are just the transmission and reception points. The real magic happens in the domes, which is where this whole theory stops sounding crazy and starts sounding absolutely terrifying in its implications. Domes in classical and Victorian architecture are massive, complex structures that require enormous effort to build. The official explanation for why every important building needed a dome is essentially, they look impressive and create nice interior spaces. Which, sure, fine, except that explanation completely ignores the absolutely bonkers level of precision that went into constructing these things. We're not talking about eyeballing it and hoping for the best. We're talking about mathematical precision in every dimension: radius, height, thickness, the exact composition of the materials used, even the acoustic properties of the interior surfaces. Modern architects analyzing these domes have found that many of them have acoustic sweet spots where sound behaves in unusual ways, creating perfect resonance at specific frequencies. The official explanation is usually something like, well, they wanted good acoustics for music and speeches, which would be believable if every single dome happened to resonate at roughly the same frequency range. But they do. Across different cities, different countries, different supposed builders. Almost like they were following a master blueprint that specified exact resonant properties for a reason that had nothing to do with making the choir sound nice. Here's where it gets technical, but stay with me because this is important. When you create a hemispherical structure with specific geometric proportions, and then line it with materials that have piezoelectric properties, meaning they generate electrical charges when subjected to mechanical stress, you've essentially built a resonator that can convert atmospheric pressure waves and acoustic vibrations into electrical energy. And wouldn't you know it, many of these historic domes were originally covered in or contained significant amounts of materials with exactly those properties. Quartz-heavy plasters, metallic leaf coverings, specific types of stone that just happen to have crystalline structures. Coincidence? Or engineering? Let's talk about star forts for a second, because these are possibly the most blatantly functional structures being passed off as defensive architecture. You know those geometric fortifications with the pointed star patterns that you can see clearly from aerial views? The ones that supposedly were designed to provide overlapping fields of fire for cannons? Right, because apparently military engineers across multiple continents all independently decided that a complex geometric pattern requiring massive earthworks was the best way to shoot at people. Never mind that simpler circular or square forts would be easier to build and just as effective for defense. Never mind that many of these star forts were built in locations where they made no strategic military sense whatsoever. What these star forts actually look like, when you study their geometry, is capacitors. And I don't mean in a vague metaphorical sense. I mean they follow the same geometric principles as modern capacitor designs, with alternating layers of conductive and non-conductive materials arranged in precise patterns to store electrical charge. The star pattern itself creates multiple points where electrical potential can concentrate, and the earthworks provide the mass and material composition necessary to hold that charge. These weren't designed to store gunpowder. They were designed to store electricity, which, naturally, is not something you'll find in any mainstream historical analysis, because that would require admitting that someone in the past understood electrical engineering principles that we supposedly didn't discover until much later. Now here's the critical point that ties all of this together. These buildings, the ones with the spires, domes, and starfort foundations, weren't scattered randomly across the landscape. They formed a network. Plot them on a map and patterns emerge. Alignments with magnetic anomalies. Spacing that suggests they were meant to relay or distribute energy between points. Clusters around specific geographic features that just happen to have unusual electromagnetic properties. This isn't pattern seeking and random noise. This is geometric precision that becomes obvious once you actually look at the data instead of dismissing it out of hand. And this is exactly why these structures had to be installed from above by atmospheric vessels with millimeter precision. If you're building a radio tower today, you need to get the orientation exactly right for optimal signal transmission and reception. You need to account for magnetic field lines, local interference, elevation relative to surroundings, all sorts of factors that require precision placement. Now imagine you're doing that in an era before GPS, before precise surveying equipment, before computer modeling. The only way to get it right is to have a bird's-eye view and the ability to hover while making fine adjustments, which is exactly what those atmospheric vessels provided. The aerial installation wasn't just about convenience or showing off. It was necessary because these buildings had to be oriented with extreme precision relative to Earth's magnetic field lines. Get the orientation wrong by even a few degrees, and your energy node doesn't function properly. It's like trying to aim a satellite dish while standing on the ground, versus doing it from a helicopter with a perfect view. One method gives you precision, the other gives you a headache and a non-functional system. This also explains something else that's always puzzled historians. Why were these massive buildings completed so quickly? We're talking about structures that today would take 5 to 10 years to build being finished in 18 months, 2 years tops. The standard explanation involves vague hand-waving about better work ethic and more available labor, which doesn't actually explain anything. Building is building. There's only so fast you can lay bricks and pour concrete, regardless of how motivated your workers are. Unless, of course, you're not building in the conventional sense at all. If you're assembling prefabricated components that were manufactured elsewhere and then precisely installing them from above, suddenly those timelines make perfect sense. It's the difference between building a computer from scratch versus snapping together pre-made parts. One takes forever, the other takes an afternoon. The materials themselves tell a similar story. Modern analysis of the construction materials from buildings of this era often reveals some weird stuff. Concrete with unusual aggregate compositions that shouldn't work according to modern understanding, but somehow do. Metal framework with alloy ratios that don't match what was supposedly available at the time. Stone blocks cut with precision that would require modern diamond-tipped tools, yet somehow they managed it with, what, chisels? And these anomalies aren't occasional quirks. They're consistent across buildings that are supposedly unrelated, built by different people, in different places. Almost like they came from the same manufacturing source, which would make sense if they were components in a standardized system rather than individual custom constructions. Let's address the obvious question. If these buildings were energy generators or nodes, where's the wiring? Where are the obvious technological components? Great question, and the answer is, you're looking at them. You just don't recognize them as such, because they're integrated into the architecture itself. Those decorative metal railings? Conductors. Those elaborate ceiling medallions? Junction points. Those ventilation shafts that go down into the basement? Cable runs. The technology isn't hidden. It's disguised as ornamental architecture, which is actually brilliant if you think about it, because it means the system can function in plain sight without anyone questioning what they're looking at. The basement levels of these buildings are particularly fascinating, because this is where you find the real technical infrastructure. Many of these structures have extensive underground chambers that are officially described as storage spaces, furnace rooms, or vague utility areas. But when you actually go down there, you find spaces that are way too elaborate for simple storage. Tiled walls that serve no practical purpose unless you're trying to create a clean, non-conductive surface. Unusual architectural features like niches in walls at specific heights and intervals. Drainage systems that seem overbuilt for managing rainwater, but would make perfect sense if they were dealing with condensation from electrical systems or cooling requirements for equipment. And in many cases, these basement spaces connect to each other through tunnel systems that officially don't exist, but that everyone who's ever explored these buildings knows are there. The ceiling heights in these buildings are also worth noting. Many of them have interior spaces that are absurdly tall by any practical standard. A 30-foot ceiling might look impressive, But from a functional standpoint, it's a massive waste of heating and cooling resources. Unless, of course, you need that vertical space for something other than aesthetics, like, say, allowing electrical charges to distribute properly without arcing to the floor, or creating resonant chambers for specific frequencies, or accommodating equipment that needs to be suspended at specific heights. Suddenly, that impractical ceiling height becomes a design requirement rather than an aesthetic choice. Here's something else that's weird. Many of these buildings, particularly the exhibition halls and World's Fair pavilions, were supposedly temporary structures that ended up being used for decades or even still standing today. The official story is that they were built so well that people didn't want to tear them down, which is nice, but doesn't really make sense economically. You don't build temporary structures with the same level of quality and expense as permanent ones. That's not how construction budgets work. Unless the temporary designation was cover for installing components of the energy grid network without raising questions about why you're spending millions on infrastructure for a 3-month exhibition. Oh, it's just for the fair. Don't worry about all those metal spires and elaborate dome structures we're installing. Then the fair ends, but the temporary buildings stay because, whoops, they're actually critical nodes in the electrical grid and we can't remove them without disrupting the whole system. The architectural plans for these buildings, when you can find them, are often suspiciously vague about certain details. You'll get beautiful renderings of the exterior, detailed floor plans for the public spaces, but then oddly sparse information about the technical infrastructure. It's like looking at a blueprint for a modern data center that shows you where all the desks go, but mysteriously has no information about the server rooms or cooling systems. The important stuff, the stuff that would reveal what the building actually does, is either missing, classified, or so heavily redacted that it might as well not exist. And then there's the maintenance question. These buildings required constant upkeep of their decorative elements, specifically the metalwork. Regular polishing, cleaning, replacement of components that wore out. Why would decorative elements need such intensive maintenance? Because they weren't decorative, they were functional, and they needed to be kept in proper working condition. The metal couldn't be allowed to corrode or tarnish because that would affect conductivity. The geometric elements had to remain precise because that affected resonant properties. This wasn't about keeping things pretty, it was about keeping the system operational. When these buildings were renovated in later decades, something interesting happened. Elements were removed or replaced with materials that looked similar but had different properties. Copper roofing replaced with modern alternatives. Metal framework swapped out for cheaper materials. Interior finishes changed in ways that destroyed acoustic properties. And in every case, the official explanation was about cost savings or modernization. But the result was systematically dismantling the functional components while preserving the appearance. It's like replacing all the electronics in your computer with wooden blocks painted to look like circuit boards. It still looks like a computer, but it doesn't do anything anymore. This brings us back to why the atmospheric vessels were so critical. These buildings weren't just being placed, they were being calibrated. The vessels could hover, adjust position by millimeters, rotate components to exact orientations, all while maintaining perfect stability. Try doing that with cranes and scaffolding, and you'll spend months getting it wrong before you accidentally get it right. But with an atmospheric vessel, you could position a dome or spire in minutes, make micro-adjustments based on readings from instruments, and lock it into place with the precision necessary for the system to function. This wasn't construction, it was installation, and there's a big difference. The technology behind all of this, the atmospheric electricity capture, the resonant energy conversion, the distribution through architectural networks, this wasn't primitive or experimental. This was mature, debugged, standardized technology being deployed at scale across the globe. And then it was deliberately forgotten, dismantled, and buried under a comfortable story about decorative architecture and construction techniques that don't actually make sense when you examine them closely. Which raises the final, uncomfortable question. Who benefits from humanity not having access to free atmospheric energy? And what would they do to keep it that way? Now that we've established that these buildings were functional machines rather than pretty decoration, let's talk about the most technically demanding component of the whole system, the domes. Because if you thought installing a building with millimeter precision was challenging, try installing a dome that has to maintain perfect geometric relationships while also functioning as a piezoelectric resonator that converts atmospheric pressure and sound waves into electrical energy. No pressure, right? Just hover your multi-ton airship perfectly still while lowering a massive hemisphere that needs to be accurate to tolerances that would make a Swiss watchmaker nervous. The domes from this era weren't just impressive architecture. They were incredibly sophisticated pieces of technology, disguised as beautiful structures. And I mean that literally. When modern engineers analyze the material composition of original dome coverings that somehow survived later renovations, they find some genuinely bizarre stuff. We're talking about plaster mixtures with silicon content way higher than what you'd use for normal construction. And before you say, maybe they just like sparkly plaster, silicon dioxide, quartz, is piezoelectric. Hit it with mechanical pressure and it generates electrical charge. Subject it to electrical fields and it vibrates at precise frequencies. This isn't construction material. This is functional crystal engineering embedded in what everyone assumes is just fancy interior decoration. But it gets better. Many of these domes also had metallic inclusions mixed directly into the plaster. Tiny particles of copper, bronze, sometimes even gold dispersed throughout the material. The official explanation, when historians bother to provide one, is that this was for decorative shimmer or preservation properties. Because naturally, when you're building on a budget, which these projects supposedly were, your first thought is, let's add gold flakes to the ceiling plaster. That makes total sense if you've never had to justify construction expenses to anyone ever. The actual reason for metallic inclusions is that they create a conductive matrix within the crystalline structure, essentially turning the entire dome surface into a distributed antenna and resonator. It's not decoration, it's infrastructure. The geometry of these domes is also suspiciously precise in ways that go way beyond aesthetic preference. Measure the radius, height, and thickness of original domes from different buildings, different cities, different countries, and you'll find they follow remarkably similar mathematical ratios. Specifically, many of them conform to the golden ratio, or other harmonic proportions that are significant in physics, not just art. That's not because architects across the globe all independently decided they liked the same shape. It's because these ratios create specific resonant frequencies when the structure is complete. Get the geometry even slightly wrong, and the resonance doesn't work. Your beautiful dome becomes an expensive, non-functional ornament that looks right, but doesn't do anything. This is exactly why atmospheric vessels had to install these domes with such obsessive precision. We're not talking about close enough measurements here. We're talking about needing to align the dome so that its axis matches magnetic field lines within a fraction of a degree. We're talking about positioning it so that the resonant frequency of the structure matches specific atmospheric conditions. Try doing that with ropes, pulleys, and manual labor, and you'll be there for months making tiny adjustments while hoping you don't drop the whole thing and have to start over. But with an airship that can hover perfectly still while operators make micro-adjustments based on real-time measurements, suddenly that seemingly impossible installation becomes not just possible, but routine. The installation process itself must have been absolutely spectacular to witness. Imagine watching a massive dome being lowered from the sky, held perfectly level by an atmospheric vessel, while workers on the ground and operators in the air coordinate the final placement. There would have been acoustic signals, specific tones that indicated when alignment was correct, changes in pitch showing when adjustments were needed. The dome itself would start resonating as it approached proper placement, creating audible feedback that operators could use for fine-tuning. This wasn't just construction. It was calibration of a precision instrument that happened to look like a building component. And here's the really damning evidence. When these domes get restored in modern times, they stop working. I don't mean they collapse or crack. I mean whatever functional properties they originally had disappear. You can find documentation of buildings where, after restoration, the acoustic properties of the dome changed dramatically. Frequencies that used to resonate perfectly suddenly don't. Temperature regulation that worked mysteriously stops functioning. The official explanation is usually something vague about changes in materials or techniques. But what actually happened is that the restoration destroyed the precise geometric and material properties that made the dome functional. It's like taking apart your smartphone and putting it back together with roughly the right-looking parts. Sure, it might still look like a phone, but good luck making calls with it. Modern restorers approach these domes as if they're purely structural and decorative elements. They replace damaged sections with close-enough materials. They use modern techniques that are cheaper and faster, but don't replicate the original properties. They make improvements that actually break the functionality. And then everyone wonders why the restored dome doesn't have the same character or atmosphere as the original. Well, duh. You just replaced a functional piezoelectric resonator with a fancy ceiling that does nothing except keep the rain out. Congratulations! You've successfully created an expensive ornament from what used to be working technology. But here's where this story gets even more interesting. What you see above ground, the impressive dome, the soaring spire, the elaborate exterior, that's just the visible tip of a much larger system. These buildings weren't just tall structures planted on the surface. They were complete systems that extended deep underground, with the subterranean components being just as critical to functionality as the parts everyone can see. And this underground infrastructure is where things get really, really suspicious. Official records describe these underground levels as basements, storage areas, mechanical rooms, boring, utilitarian spaces that nobody thinks twice about. But when you actually explore these spaces, you find architecture that makes absolutely no sense for simple storage. We're talking about elaborate tunnel systems connecting buildings across entire city blocks, vaulted chambers with acoustic properties that rival the above-ground spaces, tiled walls and ceilings in areas where nobody would ever see them, unless they're specifically designed to be clean and non-conductive surfaces for technical equipment, drainage systems that are wildly overbuilt for managing rainwater, but would be perfect for condensation from electrical systems or cooling requirements for energy storage. The scale of these underground networks is also completely disproportionate to what the above-ground buildings would need for normal operation. You'll find a 3-story building with 5 levels of basement and sub-basement extending down into the earth, connected to neighboring buildings through tunnels that don't officially exist, but that urban explorers keep finding. The official explanation is usually something about flood control or utility access, which would be believable if these tunnels didn't include architectural features like niches, alcoves, and specialized chamber designs that have nothing to do with moving water or running pipes. What these underground spaces actually represent is the other half of the energy system. If the above-ground structures were the reception, transmission, and resonation components, then the underground levels were the storage, stabilization, and distribution infrastructure. Think of it like a modern power grid. You need the generation sources, but you also need transformers, substations, capacitor banks, and distribution networks to actually deliver power where it's needed. These underground chambers served exactly those functions for the atmospheric energy being captured by the buildings above. The construction of these underground levels also presents some interesting questions. Many of them show evidence of being built using techniques that don't match the supposed construction timeline of the buildings above them. You'll find precision-cut stone blocks in basements of buildings that were supposedly constructed with brick and mortar. You'll find architectural styles in the foundations that predate the supposed era of construction by century. The standard explanation is that these are older structures that were incorporated into newer buildings, which raises the obvious question. If the older structures were so well built that they could be reused as foundations, why did the civilization that built them supposedly collapse or disappear? Why were these advanced foundation techniques lost and then later rediscovered? Unless, of course, they weren't lost. They were deliberately obscured. The tunnel networks between buildings are particularly fascinating because they reveal patterns that make no sense from a conventional construction perspective. These tunnels don't just connect adjacent buildings haphazardly. They form geometric networks with specific angles and intersections. Buildings that have no obvious above-ground relationship turn out to be connected underground in ways that suggest coordinated installation as part of a unified system. It's like discovering that all the buildings in your city are secretly connected through a network that nobody knew about, because everyone was so focused on the street-level architecture they never bothered to look down. And here's the critical connection between above and below. The atmospheric vessels installing components above ground had to coordinate with the underground infrastructure. You couldn't just drop a dome or spire randomly on top of a building and call it done. The above-ground component had to align precisely with the underground chambers and tunnel connections to complete the electrical circuit or energy pathway. This means the installation crews in the airships were working from detailed knowledge of what was underneath the buildings they were completing. They weren't just construction workers. They were system integrators, connecting visible and invisible components of a larger network. This also explains why certain buildings have weird architectural features that seem to serve no purpose, until you realize they're alignment markers for aerial installation. Those geometric patterns on rooftops that supposedly are purely decorative, they're targeting guides showing airship pilots exactly where components need to be placed relative to underground infrastructure. Those odd protrusions or recesses in walls, access points for calibration instruments that needed to verify alignment between above and below. These aren't design quirks, they're functional elements of the installation process that got preserved in the finished structure. The ventilation systems in these buildings are another giveaway. Official descriptions call them simple air circulation for comfort and health. But when you actually study the layouts, they're way too elaborate for that purpose. These aren't just shafts for moving air around. They're precisely engineered pathways connecting above-ground and underground spaces with specific dimensional requirements. Many of them include features like baffles, chambers, and turns that make no sense for ventilation, but would be perfect for managing electrical fields or distributing energy without creating dangerous accumulations in any one area. It's less, let's get some fresh air in here, and more, let's prevent electrical discharge from arcing across spaces where people might be standing. The really damning evidence is what happens when modern renovations disrupt these underground spaces. Buildings that were known for having unusual electromagnetic properties, compasses that don't work properly, electronic devices that behave strangely, unusual temperature regulation, suddenly normalize after their basements get upgraded with modern concrete, modern drainage, modern everything. The official story is that these quirks were just problems that got fixed. The alternative interpretation is that functional components got destroyed and replaced with non-functional modern substitutes, effectively lobotomizing the building's technical systems while preserving its appearance. There's also the matter of what's been found in these underground spaces when they're actually explored, rather than just sealed off or filled in. Urban explorers and historians who've gotten access to undisturbed sections report finding metal framework that doesn't match any above-ground construction, ceramic insulators similar to what you'd use for high-voltage electrical systems, and evidence of sophisticated drainage that suggests these spaces regularly dealt with condensation from temperature-controlled equipment. None of this makes sense for simple basements, but all of it makes perfect sense for technical infrastructure supporting an energy system. The coordination between atmospheric vessel installation and underground infrastructure also explains another mystery. Why do so many of these buildings have rooftop access that seems overbuilt for its purpose? Wide doorways, reinforced structures, platforms that are way more substantial than you'd need for basic maintenance. The official explanation is that they needed to be built strong just in case, but that's not how construction budgets work. You don't over-engineer expensive rooftop structures for hypothetical future needs when you're supposedly building on tight timelines and limited funds. But if you need regular access for airship docking to maintain or adjust the energy collection systems, then suddenly those robust rooftop structures make perfect sense. They weren't maintenance access. They were docking platforms for the vessels that installed and serviced the system. What we're looking at, when we put all these pieces together, is evidence of a complete energy infrastructure that operated both above and below ground, installed with precision that required aerial coordination, and deliberately obscured through selective preservation and renovation that kept the impressive visible elements while systematically destroying or hiding the functional components. The domes weren't just pretty. They were the key resonant elements in a system that also required precise underground infrastructure to function. Together, they formed a network that captured, stored, and distributed atmospheric electrical energy across entire cities, possibly across continents. And then, for reasons we'll explore later, this entire system was systematically dismantled, forgotten, and replaced with a comfortable narrative about impressive but purely decorative architecture that required conventional construction methods. Which, naturally, is exactly the story that energy companies would want you to believe if they were trying to ensure you stayed dependent on their services, rather than questioning why we no longer use the free atmospheric electricity that buildings use to harvest automatically. But I'm sure that's just a coincidence. Let's talk about the actual materials used in these structures, because when you start analyzing the metal components from this era, things get weird fast. And I don't mean, oh, that's interesting weird. I mean, this shouldn't be possible with the technology they supposedly had weird. Modern metallurgists examining metal samples from the 19th century architecture keep finding alloy compositions that make them scratch their heads and quietly update their assumptions about what was achievable in that period. Which is academic speak for, we have no idea how they did this, but we're not going to admit it publicly because that would be embarrassing. Take the metalwork in star forts, for example. These geometric fortifications that we discussed earlier as being giant capacitors rather than defensive structures, the metal components, railings, gates, decorative elements, structural reinforcements, they're not just iron or basic steel. Chemical analysis reveals alloy compositions with trace elements in proportions that are genuinely puzzling. You'll find steel with specific amounts of manganese, chromium, and nickel that create properties modern metallurgists recognize as deliberate engineering choices, not accidents. These aren't close enough mixtures from someone eyeballing ingredients. These are precise formulations designed to achieve specific electrical and magnetic properties. And here's where it gets fun. Some of these alloys display what's called non-magnetic behavior, meaning they don't respond to magnets the way normal steel does. Except they're not actually non-magnetic in the conventional sense. They interact with magnetic fields in really specific, controlled ways. It's like the difference between something that ignores magnets completely versus something that has a complicated relationship with them. Modern engineers would kill to know how to create these materials because they'd be incredibly useful for precision electronics and electromagnetic shielding. Yet somehow, 19th century foundries were allegedly pumping out tons of this stuff for decorative architecture. Sure, and my grandmother's cookie recipe was actually a secret formula for rocket fuel. The processing techniques are equally suspicious. When you examine the microstructure of these metals under microscopy, which is basically CSI for materials science, you find grain patterns and crystal formations that indicate very specific temperature regimes during forging and cooling. These aren't the patterns you'd get from conventional furnaces of the period, which had limited temperature control and produced fairly rough, inconsistent results. These are the patterns you'd see from precisely controlled heat treatment, the kind of process that requires constant monitoring and adjustment to achieve. The official explanation is that 19th century metalworkers were just really, really good at their jobs and had amazing instincts for temperature management. The alternative explanation is that they had better equipment than we think they did, or they were working with materials and techniques that didn't survive into the historical record. But wait, it gets better. The metal inclusions in stonework, those decorative-looking metal elements embedded in or attached to stone blocks, they're not decorative. Well, okay, they look decorative, but that's clearly not their primary function. These metal pieces are positioned with geometric precision, creating patterns that span across multiple stone blocks, and sometimes across entire facades. They're aligned with each other in ways that have nothing to do with aesthetics, and everything to do with creating conductive pathways through what would otherwise be non-conductive stone. It's like discovering that the decorative studs on your jeans are actually functional components of a hidden electrical circuit. Fashion with a purpose, if you will. The really telling detail is how these metal inclusions are integrated into the stonework. They're not just stuck on the surface. They're embedded with precision that suggests they were installed during initial construction as functional components, not added later as decoration. Try embedding metal into stone with millimeter precision using 19th century tools and techniques, and you'll understand why this shouldn't work as well as it does. Yet building after building shows this same level of integration, suggesting it wasn't a difficult or unusual process for the original builders. Almost like they had standardized methods for creating conductive pathways through architectural elements, which is exactly what you'd want if you were building an energy distribution system disguised as decorative buildings. The weight properties of these metal components are also fascinating. Many of them are significantly lighter than they should be for their size and apparent composition. Not impossibly light, we're not talking about floating metal here, but light enough that aerial installation becomes much more practical than it would be with conventional materials. Creating lightweight but strong metal alloys is something modern aerospace engineering obsesses over, because reducing weight while maintaining strength is critical for anything that needs to fly. Somehow, 19th century architecture was apparently using these same principles for decorative elements on buildings. Because clearly, the number one concern when designing ornamental railings is making sure they're optimized for air transport. That's definitely a thing that makes sense if you don't think about it. Now let's talk about how these vessels actually installed components with such obsessive precision, because this is where the engineering gets genuinely impressive. You've got a massive airship hovering hundreds of feet in the air, holding a multi-ton architectural element that needs to be positioned with millimeter accuracy. No GPS, no laser guidance, no computer-controlled stabilization systems. Just human operators, some instruments, and a really good understanding of physics. How on Earth, or rather, how above Earth, did they pull this off? The answer is acoustic alignment, which is both brilliantly simple and incredibly sophisticated. See, properly designed architectural elements resonate at specific frequencies when they're correctly positioned relative to magnetic field lines and other structural components. Get the alignment right, and the structure produces a clear, stable tone. Get it wrong, and the tone is off, distorted, or absent entirely. It's like tuning a massive musical instrument where the building itself is the resonator, and you're adjusting by moving multi-ton components through three-dimensional space. No big deal. Just casual precision installation using sound as your primary feedback mechanism. The operators in the atmospheric vessels would have instruments, probably something like tuning forks or resonance chambers, calibrated to specific frequencies. As they lowered a component into position, Ground crews would be monitoring the acoustic output of the existing structure and signaling changes to the airship crew. A little left. Forward 2 inches. Rotate clockwise 5 degrees. All coordinated through a combination of visual signals and acoustic feedback, because apparently, in the 19th century, they had better nonverbal communication protocols for precision engineering than most modern construction crews have with radios and smartphones. Kind of embarrassing when you think about it. The visual markers on buildings that we've mentioned before, those geometric patterns, concentric circles, spiral designs, they weren't just targeting guides for where to place components. They were calibration references that allowed airship pilots to judge position, distance, and alignment from their aerial perspective. It's the same principle modern aircraft use with runway markings, except instead of helping planes land safely, these markers helped airships install building components with precision that would make modern crane operators weep with inadequacy. And they did it without any of the digital assistance we consider absolutely essential today. The ground coordinator system was equally sophisticated. You have teams positioned at specific points around the building, each with sightlines to both the airship and the installation point. They'd use standardized signals, flags, lights, sound instruments, to communicate positioning information. The airship crew would integrate feedback from multiple ground stations to determine exact positioning in three-dimensional space. It's basically human-powered GPS, except instead of satellites in orbit, you've got people with really good spatial reasoning and probably excellent musical pitch standing on rooftops. Low tech in implementation, but high concept in execution. The synchronization between above and below was critical, especially when installing components that connected to underground infrastructure. The ground crews would have to confirm not just that the visible positioning was correct, but that the underground alignment was proper as well. This means they had methods for determining subsurface conditions and positions without being able to see them directly. Probably using acoustic resonance again, sending signals through the existing structure and measuring how they propagated through underground chambers and tunnels. It's like echolocation, but for architecture. Bats would be proud. The actual installation sequence would have been carefully choreographed. First, the airship approaches with the component secured and properly oriented. Ground crews verify that the approach vector is correct. As the vessel begins to lower the component, acoustic instruments start measuring resonance, looking for the characteristic tones that indicate proper alignment. Fine adjustments are made based on real-time feedback from multiple observation points. The component is lowered into position where it would mate with existing structural elements, probably with tolerance for adjustment, but not much, because remember, we're building resonant systems where geometry matters. Final positioning is confirmed both acoustically and visually. The component is secured, and the airship releases its hold. The whole process might take hours for a complex installation, but the result is precision that modern construction methods with all their fancy equipment struggle to match. What's really impressive is that this system worked reliably enough to be used repeatedly across multiple sites, different operators, and varying conditions. This wasn't experimental technology where every installation was a coin flip between success and disaster. This was mature, debugged, standardized procedure that had been refined through extensive use. The fact that it worked so well suggests there was significant institutional knowledge and training infrastructure supporting it. Schools or guilds that trained operators, manuals that documented procedures, probably regular certification and quality control processes, all of which have mysteriously vanished from the historical record, because apparently, an entire industry of highly specialized aerial installation workers just decided one day to pack up and leave without telling anyone where they went or training any successors. The instruments used for this precision work are another fascinating missing piece. You'd need specialized devices for measuring resonant frequencies, determining alignment relative to magnetic fields, verifying geometric relationships in 3 dimensions. Basically a whole toolkit of technical equipment that should exist in museums somewhere. But where are the airship-mounted resonance meters? Where are the acoustic alignment instruments? Where are the magnetic field detectors that would have been essential for proper installation? They're not in museums because museums don't collect things they don't believe existed in the first place. And they don't believe these things existed because the official history says they couldn't have existed. It's beautifully circular logic that conveniently erases an entire technology from the collective memory. The training requirements for this work would have been substantial. Operating an atmospheric vessel was probably complicated enough, but doing so while performing precision installation work? That requires skills that take years to develop. spatial reasoning, understanding of acoustics, coordination with ground crews, real-time problem solving when things don't align perfectly. These aren't skills you pick up over a weekend workshop. Yet somehow, there are no records of institutions that trained aerial installation crews. No apprenticeship programs documented. No guild records preserved. It's like if modern commercial pilots just appeared fully trained without any of the flight schools, regulations, or certification programs that we know are necessary to create them. The logistics of coordinating these installations across multiple sites are also mind-boggling when you actually think about them. You've got atmospheric vessels that are expensive to operate and can only do one installation at a time. You've got building components that need to be fabricated, transported to the site, and installed in specific sequences. You've got ground crews that need to be trained and positioned. You've got weather conditions to consider, because precision aerial work in bad weather is a recipe for disaster. All of this requires project management and coordination on a scale that would challenge modern construction firms with their computers and communication systems. Yet somehow, the 19th century was allegedly doing this routinely across multiple countries without any of the organizational infrastructure that we'd consider essential today. And here's the final kicker. This entire system, with its sophisticated metallurgy, precision installation protocols, acoustic alignment techniques, and coordinated ground and air operations, all of it disappears from the historical record around 1912 to 1915. Not gradually, as old technology is replaced by new, but suddenly, as if someone flipped a switch. Buildings that were being installed with aerial precision one year are being constructed with conventional methods the next. Atmospheric vessels that were photographed regularly just stop appearing. The highly trained specialists who operated this system either retire en masse without training successors, or they quietly transition into other professions without anyone noticing that an entire highly specialized industry has evaporated. The official history treats this as unremarkable, just the natural evolution of construction techniques as dirigibles and cranes became more common. But that explanation only works if you ignore the fact that the new methods were objectively worse at many tasks than what they replaced. Modern cranes can't achieve the positioning precision that atmospheric vessels apparently could. Modern construction timelines are longer for comparable projects. Modern materials, despite all our advances, often lack the specific properties we find in samples from this era. It's not progress, it's regression disguised as progress, and the disguise is only convincing if you don't look too closely at what was actually lost. So why would someone deliberately dismantle a functional system and replace it with inferior methods? Well, that's a question with some uncomfortable answers that we'll explore in the next section. But I'll give you a hint. Follow the money. Specifically, follow the money that flows into the pockets of companies that control energy generation, distribution, and infrastructure. Then ask yourself whether those companies would want a world where buildings generate their own power from atmospheric electricity and don't need to be connected to centralized grids. The answer might just explain why an entire technological system mysteriously disappeared right when it would have been most useful. So we've established that there was this incredibly sophisticated atmospheric energy system operating globally, with precision-installed architecture, advanced metallurgy, and coordinated aerial operation. Everything's working great. Humanity has free energy from the atmosphere, and life is good. Then something happens in the early 19th century, specifically around 1812, that breaks everything. And I mean catastrophically, irreparably breaks it. Whatever this event was, it damaged the planetary energy grid so severely that the rest of the century becomes one long, desperate attempt to patch a system that's fundamentally dying. And here's the kicker. We have almost no clear documentation of what actually happened, which is itself incredibly suspicious for an event that apparently reshaped global infrastructure. The historical record around 1812 is weirdly fuzzy, considering its relatively recent history. You get Napoleon's invasion of Russia, the War of 1812 in North America, various other conflicts, plenty of military history. But there are also reports of unusual atmospheric phenomena, strange weather patterns, and what contemporary sources describe as disturbances in the natural order that don't get much attention in modern histories. Because naturally, when historians compile records, they focus on the battles and politics, and conveniently ignore the part where multiple independent sources across different continents mention the sky doing things it's not supposed to do. That's probably not relevant, right? One possibility is a massive solar storm, the kind of electromagnetic event that would induce powerful currents in any conductive system on Earth's surface, which is exactly what a planetary network of electrically active buildings would be. Modern solar storms can knock out power grids and fry electronics. Imagine what a really big one would do to a civilization whose entire infrastructure is essentially one giant antenna network. The Carrington event of 1859 was bad enough, but that was almost 50 years after 1812, by which point the system was already degraded or shut down. Whatever hit in 1812 might have been substantially worse, arriving when the energy grid was still fully operational and therefore maximally vulnerable to electromagnetic disruption. Another possibility is tectonic activity, major earthquakes or volcanic eruptions that disrupted the precise geometric relationships necessary for the system to function. Remember, these buildings had to be positioned with millimeter accuracy relative to magnetic field lines and underground infrastructure. Shift the ground even slightly, and your carefully calibrated energy nodes are now misaligned, creating dead zones in the network. A series of major seismic events across multiple continents could fragment the global grid into isolated sections, each of which would start failing as they lost connection to the larger system. It's like having a power grid where every substation suddenly gets knocked a few degrees off true. Nothing explodes immediately, but the whole thing stops working efficiently and starts degrading rapidly. There's also the uncomfortable possibility of deliberate sabotage, which sounds like conspiracy theory territory, until you remember that there were absolutely groups who would benefit from disrupting a system of free atmospheric energy. Emerging industrial interests based on coal, steam power, and centralized production would have seen the atmospheric energy system as an existential threat to their business models. Hey everyone, stop burning our expensive coal and using our expensive machinery because the buildings are generating free electricity from the air, is not a message that fossil fuel barons want spreading. Whether through direct action or simply capitalizing on natural disaster to push their alternatives, these interests had every incentive to see the old system fail. Whatever the cause, the effects are clear in the historical record, if you know what to look for. After 1812, you see a massive shift in how major building projects are described. Before this date, construction timelines are short, and documentation is sparse on methodology. After 1812, construction takes longer, costs more, and suddenly everyone is very interested in documenting exactly how things are being built, almost like they're trying to figure it out as they go, rather than following established procedures. It's the difference between experts executing routine tasks and people desperately trying to reverse engineer a system they no longer fully understand. The period from 1812 to about 1880 is like watching a civilization slowly realize that something essential is broken. Buildings continue to be constructed in the old style, the spires, domes, geometric precision, but there's increasing evidence that they're not functioning as intended. Maintenance records start mentioning inexplicable failures of building systems. Atmospheric vessels become less common in documentation, suggesting they're either breaking down or being taken out of service. And critically, the training programs for aerial installation crews seem to collapse, with fewer and fewer skilled operators available as the older generation retires without adequate successors. It's a death spiral, where the system needs maintenance it can't get because the people who knew how to maintain it are disappearing faster than new ones can be trained. Then comes the construction boom of 1880 to 1910, which history books describe as a period of rapid industrialization and architectural ambition. But look closer, and it's actually something else. A last-ditch attempt to repair the failing energy grid using the remaining functional atmospheric vessels and the knowledge of the final generation of operators who still remembered how things were supposed to work. This is why you see such concentrated building activity during this period. It's not expansion, it's emergency restoration. They're racing against time to fix nodes in the network before the last airships fail and the last experienced crews retire. The scale of construction during this period is genuinely remarkable. Entire city centers rebuilt, massive exhibition halls constructed in months, infrastructure projects that seem absurdly ambitious for the supposed technology of the era. Because they're not ambitious, they're desperate. When your planetary energy system is dying, you don't have the luxury of taking your time. You throw every available resource at the problem and hope you can patch enough nodes to keep the network limping along. The World's Fairs and international exhibitions of this era weren't just showing off. They were attempts to build new energy nodes under the cover of temporary structures, probably hoping that the restored network effect would somehow revive them. Failing system. But it doesn't work. By 1912, it's clear that the restoration efforts have failed. The network is too damaged, too many key nodes are offline, and the remaining atmospheric vessels are failing faster than they can be maintained. The technology is dying, and the people who understand it are dying with it. And this is where things get really interesting. Because instead of doubling down on understanding and preserving what's left, there's a deliberate shift toward forgetting. Documents start disappearing from archives. Technical drawings get reclassified as decorative sketches. Photographs of atmospheric vessels in operation are edited to remove the vessels entirely, or relegated to obscure collections where nobody will find them. This isn't organic historical amnesia. This is systematic information suppression. And we can track it happening across multiple institutions simultaneously, which suggests coordination. Archives in different countries start implementing similar policies about what materials are historically significant and what can be discarded or restricted. Coincidentally, the materials that get discarded or restricted are precisely the ones that would document atmospheric vessels, aerial installation procedures, and the functional nature of architectural energy systems. Because apparently, archivists across the globe all independently decided that this specific type of documentation wasn't worth preserving. What are the odds? About the same as winning the lottery while being struck by lightning 3 times while riding a unicorn. The photographic evidence is particularly damning because we have examples of the editing process. Original photographs show clear images of atmospheric vessels during construction operations. Later copies of the same photographs have the vessels airbrushed out or obscured. Official archives will claim they don't have originals, only the edited versions, and suggest that anyone claiming to have seen the vessels in earlier versions is misremembering or falling for hoaxes. It's gaslighting on an institutional level, not just hiding evidence, but convincing people that the evidence they saw never existed in the first place. The academic side of this cover-up is equally systematic. Researchers who ask uncomfortable questions about construction methods or energy systems in historic architecture find their funding mysteriously drying up. Papers that challenge official narratives get rejected from journals for being speculative or lacking rigor, regardless of the quality of evidence presented. Academic careers get quietly derailed if scholars are too persistent in pursuing forbidden topics. And gradually, a consensus forms. Questioning the official history of 19th century construction is career suicide. So ambitious researchers learn to ask safe questions instead. It's not censorship. It's softer than that. It's just structuring incentives so that independent investigation becomes professionally unviable. Much more effective than outright bans because it makes people censor themselves. The economic motivations are glaringly obvious once you look for them. Between 1880 and 1920, you see the rise of centralized power generation and distribution companies, the ancestors of modern utility monopolies. These companies build their entire business model around being the exclusive providers of electricity, which they generate through coal, oil, and eventually hydroelectric power. They invest billions in infrastructure, power plants, transmission lines, distribution networks. Their profitability depends entirely on everyone needing to buy electricity from them, because there's no alternative source available. Now imagine what happens if buildings can generate their own power from atmospheric electricity for free. Imagine what happens if the architectural energy system gets repaired and starts functioning again. All those billions invested in centralized power infrastructure? Worthless. All those lucrative contracts for selling electricity? Gone. Every utility company would see their business model evaporate overnight. So yes, these companies have enormous incentive to ensure that nobody figures out how the old system worked or attempts to revive it. And conveniently, these same companies have the financial resources to influence archives, fund academic institutions, shape public discourse, and generally ensure that historical narratives align with their interests. The transition from atmospheric energy to fossil fuel-based power is sold to the public as progress. Look at these amazing new electric lights. Look at this modern power station generating electricity on demand. Nobody mentions that the atmospheric system did all this without burning coal or requiring centralized control. Nobody talks about how the new electrical grid is objectively worse in terms of efficiency, accessibility, and environmental impact than what it replaced. Progress is marketed so successfully that within a generation or two, most people don't even know there was an alternative. The winners write history, and in this case, the winners are the ones selling electricity by the kilowatt hour. The suppression continues into the digital age, just with more sophisticated methods. Old photographs that show atmospheric vessels mysteriously have low digitization priority in archives, meaning they remain in physical storage where few people can access them. Digital collections use metadata and search algorithms that make it difficult to find relevant images even when they've been scanned. Try searching for Airship Construction 1890s in major digital archives, and you'll get carefully curated results showing conventional construction methods and early dirigibles, nothing that challenges the official narrative. The algorithms aren't overtly censoring. They're just optimizing for results that align with established historical consensus, which happens to be the consensus that conveniently erases the inconvenient technology. Modern restoration of historic buildings continues the suppression by destroying physical evidence while claiming to preserve it. When restoring a 19th century building, conservators are trained to replicate the appearance of original materials while using modern substitutes that are cheaper, more durable, or easier to work with. This sounds reasonable until you realize that the modern substitutes systematically lack the functional properties of the originals. Conductive materials get replaced with non-conductive ones. Crystalline plasters get replaced with modern formulations that don't have piezoelectric properties. Metalwork with specific alloy compositions gets replaced with standard steel. The building looks authentic after restoration, but no longer functions as it originally did. And nobody notices because nobody believes it was supposed to do anything beyond looking pretty in the first place. What we're witnessing is a multi-generational project of enforced forgetting. Each generation learns a version of history that's one step further removed from the truth. The first generation knew the atmospheric system existed and chose to suppress information about it. The second generation learned a sanitized version, where the system existed but was primitive and ineffective. The third generation only knows the official story, where elaborate construction methods and conventional power generation have always been the only options. By now, we're several generations deep into this process, and suggesting that 19th century buildings were functional energy generation nodes sounds absurd, because it contradicts everything everyone has been taught their entire lives. But here's the thing about suppressed knowledge. It never disappears completely. There are always anomalies that don't fit the official narrative. Always physical evidence that contradicts the convenient story. Always people who notice inconsistencies and ask uncomfortable questions. The information wants to be found, and despite decades of systematic suppression, it keeps surfacing. Old photographs appear in family collections. Technical documents turn up in estate sales. Building features that don't make sense according to conventional architecture keep demanding explanation. And gradually, people start connecting dots, recognizing patterns, and reconstructing what was deliberately hidden. Which brings us to the present day, where we have an interesting situation. The atmospheric energy system is long dead, the knowledge of how to operate it mostly lost, and generations of historical revisionism have buried most evidence of its existence. But the buildings are still there. The metalwork is still there. The underground infrastructure is still there. The physical evidence can't be completely erased, only obscured and misinterpreted. And in the digital age, information that was successfully suppressed locally for a century can suddenly become accessible globally. Researchers in one country can share findings with colleagues in another. Archives that refuse to digitize certain materials find that private citizens do it anyway. The control that centralized institutions once had over historical narratives is weakening, and uncomfortable truths are becoming harder to bury. So the question becomes, now that we're starting to understand what was lost, what do we do with that knowledge? Do we attempt to reconstruct the atmospheric energy system, possibly revolutionizing how humanity generates and distributes power? Do we accept that some knowledge once lost can't be recovered without the institutional framework that originally developed it? Or do we continue pretending that free atmospheric electricity was never possible, because admitting it was would raise too many uncomfortable questions about why we're still burning fossil fuels and buying electricity from utility monopolies in the 21st century? Those are the questions we'll explore as we look at modern attempts to reverse engineer lost technology and what it might mean for our energy future. Here's where things get interesting for the present day. The technology didn't actually disappear completely. It went underground, metaphorically this time, not literally like the infrastructure we discussed earlier. Fragments of the atmospheric energy system and aerial installation methods keep popping up in modern research, usually disguised as brand new innovations that just happen to reinvent principles that were functional over a century ago. It's like watching someone patent the wheel and act like they're a genius inventor, except instead of wheels, we're talking about atmospheric density manipulation and resonant energy capture. The audacity is almost impressive. Patent databases from the 20th and 21st centuries are absolutely full of devices and methods that are suspiciously similar to what the atmospheric vessels must have used. Applications for novel methods of atmospheric ion manipulation, electromagnetic field density modulators, resonant cavity energy converters, all described as cutting-edge research into previously unexplored phenomena. Except they're not unexplored. They're rediscovered. The patent applicants either don't know they're reinventing old technology, or they know perfectly well but aren't about to mention it because that would complicate their intellectual property claims. Either way, the knowledge is slowly seeping back into public consciousness through the back door of modern engineering. Some of these patents are obviously incomplete. They describe pieces of a system without understanding how those pieces fit together. It's like finding blueprints for a carburetor without understanding that it's meant to go in an internal combustion engine. The individual component makes sense, but without the context of the larger system, you can't effectively deploy it. Other patents seem to grasp larger principles but struggle with implementation, probably because the original techniques involved materials or processes that are no longer widely available. You can't just walk into Home Depot and buy copper alloys with specific piezoelectric properties, not because they're impossible to make, but because nobody manufactures them anymore, since everyone forgot why you'd want them. The military interest in this technology is another fascinating angle that's barely hidden. Various defense departments and classified research programs have shown persistent interest in anomalous architectural structures that display unusual electromagnetic properties. Official documentation describes this as scientific curiosity about historical building techniques, which is hilarious because military research budgets aren't exactly known for funding nostalgic explorations of Victorian architecture. When the Department of Defense starts getting interested in old buildings, it's not because they appreciate Baroque aesthetics. It's because those buildings do something that modern engineering doesn't fully understand, and that represents either a potential advantage or a potential threat that needs to be studied. There are documented cases of military teams conducting surveys of specific historic buildings, taking extensive electromagnetic readings, measuring resonant frequencies, analyzing material compositions, basically treating them like archaeological artifacts that might contain functional technology rather than just pretty stonework. And then the data gets classified, because apparently the resonant properties of a 19th century courthouse are now matters of national security. This tells you everything you need to know about whether the technology was real and whether modern institutions recognize its significance, even if they're not publicly acknowledging it. The phenomenon of modern restoration destroying functional elements deserves particular attention because it's happening right now, consistently, across multiple sites. When a historic building undergoes restoration, the stated goal is always preservation, maintaining the character and integrity of the original structure. But watch what actually gets preserved versus what gets replaced, and a pattern emerges. Decorative elements that are purely aesthetic get carefully maintained or replicated with obsessive historical accuracy. But functional elements, the metalwork with specific alloy compositions, the plasters with crystalline properties, the geometric features that served resonant purposes, those get updated with modern materials that look similar but lack the original properties. Restoration architects and conservators aren't consciously destroying functional technology. They simply don't believe it was functional in the first place, so they see no reason to preserve properties that seem irrelevant to the building's appearance. It's like restoring a smartphone by replacing all the circuit boards with painted wood because you think it's just a decorative object and the electronics are unnecessary detail. From the conservator's perspective, they're being practical and responsible. From the perspective of preserving functional technology, they're systematically dismantling evidence of a lost system while thinking they're saving it. The road to historical erasure is paved with good intentions and professional best practices that are based on incomplete understanding. But here's the hopeful part. There are communities of engineers, physicists, and independent researchers who are actively trying to reverse engineer the lost technology based on architectural artifacts and historical evidence. These aren't fringe conspiracy theorists working in basements. Well, okay, some of them are working in basements. But they're also publishing papers, building experimental prototypes, and demonstrating that the principles underlying atmospheric energy capture are sound. They're taking measurements from buildings that haven't been improved with modern restoration, analyzing original materials that somehow survived, running computer simulations of how the energy network would have functioned, and gradually piecing together knowledge that was deliberately obscured. These communities face obvious challenges. Mainstream academic institutions won't touch this research with a 10-foot pole because it's still considered career suicide to seriously investigate fringe theories about lost technology. Funding is nearly impossible to obtain through normal channels because grant committees dismiss the entire premise as pseudoscience. And even when independent researchers make genuine progress, They struggle to publish findings in journals that have gatekeepers who reject anything challenging established historical narratives. So the work continues in unconventional spaces: online forums, independent publications, crowd-funded research projects, amateur experimentation. It's how knowledge advances when official institutions have decided that certain questions aren't allowed to be asked. Some of these researchers have achieved genuinely impressive results. There are documented experiments showing that architectural structures with specific geometric properties can indeed harvest measurable electrical energy from atmospheric potential gradients. Small-scale replications of resonant dome systems have demonstrated the conversion of acoustic and pressure waves into electrical charges. Metalwork fabricated using historical techniques shows unusual interactions with electromagnetic fields that modern alloys don't replicate. None of this is at the scale of the original planetary network, obviously. We're talking about proof-of-concept demonstrations, not functional power systems. But the fact that these principles work at all validates the core theory. Atmospheric energy capture through architectural resonators is physically possible, not metaphysical wishful thinking. So what would actually happen if someone successfully scaled this technology back up to functional levels? What does it mean for our energy future if we could relearn how to harvest electricity from the atmosphere using properly designed buildings? The implications are absolutely massive, and they explain why certain interests are still working to keep this knowledge suppressed, even though the original system died over a century ago. First and most obviously, it would completely revolutionize energy generation and distribution. Imagine if every building could generate its own power from atmospheric electricity, requiring no fuel, producing no emissions, and operating continuously without depending on centralized grids. Utility companies would become obsolete overnight. The entire fossil fuel industry, oil, coal, natural gas, would lose most of its market because nobody needs to burn hydrocarbons for electricity if buildings generate power automatically just by existing. We're talking about trillions of dollars in infrastructure value evaporating, along with the political and economic power that comes from controlling energy distribution. That's not a change that happens peacefully. That's a change that gets fought by every entity whose existence depends on maintaining current energy systems. Transportation would also transform dramatically if atmospheric density manipulation could be revived for vehicles. Forget about electric cars with heavy battery packs. Imagine vehicles that move by manipulating the air around them, requiring no conventional fuel and no energy storage beyond what's needed for control systems. Aerial transport becomes practical for cargo and construction again, except this time we'd understand the principles well enough to standardize and expand them. The aerospace industry would have to completely rethink its approach to flight. And again, every industry that profits from current transportation methods, petroleum companies, automotive manufacturers, aerospace contractors, would resist this transition with every resource at their disposal. Construction would return to methods that look insane by current standards, but are actually more efficient. Precision aerial installation of prefabricated components, buildings completed in months instead of years. Structures built to serve dual purposes as architecture and energy infrastructure. Modern construction is a massive industry worth hundreds of billions globally, built entirely around conventional methods that require extensive labor, heavy equipment, and long timelines. Introduce aerial installation technology that cuts construction time and labor requirements by 70%, and you've just threatened the business model of every construction company on Earth. They're not going to embrace that disruption enthusiastically. The geopolitical implications are also staggering. Currently, energy resources are distributed unevenly. Some countries have oil, some have natural gas, some have hydroelectric potential, and those resources create power dynamics that shape global politics. Nations with energy resources have leverage over nations without them. But atmospheric electricity is everywhere. Every country could become energy independent immediately if they knew how to build proper harvesting infrastructure. The entire basis of modern geopolitical energy politics would dissolve. That sounds wonderful from a humanitarian perspective, but from the perspective of nations that currently benefit from energy-based influence, that's a threat to their power that needs to be prevented, not enabled. There's also the uncomfortable question of whether we actually should restore this technology, even if we could. The 1812 catastrophe, whatever it was, damaged the original system badly enough that subsequent restoration attempts failed, and the entire network collapsed. What happens if we rebuild it and trigger similar problems? What if the planetary energy grid had side effects or failure modes that we don't understand because the original operators never documented them, or their documentation was among the materials that got systematically suppressed? Humanity has a fairly consistent track record of deploying powerful technologies before fully understanding their consequences. Atomic energy, industrial chemistry, fossil fuel combustion. We figured out how to use them and only later realized the problems they created. Do we want to add atmospheric energy networks that might destabilize planetary electromagnetic fields to that list? This is a genuine ethical dilemma without easy answers. On one hand, we face climate change, energy poverty, and resource conflicts that atmospheric energy could potentially solve. On the other hand, we're talking about recreating a planetary-scale system that failed catastrophically once already, and we don't fully understand why or how to prevent it happening again. It's like finding the blueprints for a nuclear reactor that exploded spectacularly. Yes, it produced incredible amounts of power when it worked, but maybe we should understand the explosion part before we start building new ones. Then there's the question of who controls this technology if it's revived. The original system seems to have been relatively decentralized, individual buildings functioning as nodes in a larger network, presumably with local operation and maintenance. Modern power structures are far more centralized, with control concentrated in governments and corporations that aren't particularly interested in distributed, democratized technology. If atmospheric energy is rediscovered, will it be deployed in ways that serve broad public benefit? Or will it be captured by existing power structures and used to reinforce the same hierarchies we have now, just with different energy sources? History suggests that powerful new technologies tend to concentrate power rather than distribute it, regardless of their theoretical potential for democratization. Despite all these complications, there's something compelling about the idea of recovering lost knowledge. Humanity spent considerable effort developing the atmospheric energy system, multiple generations of experimentation, refinement, and deployment. That represents accumulated wisdom that took centuries to develop and was lost in decades. Even if we decide not to fully deploy the technology, understanding it gives us options we don't currently have. Knowledge is always valuable, even if we choose not to use it immediately. And the process of recovering this knowledge pushes us to question assumptions about what's possible, what's been tried before, and what might work differently if approached from perspectives informed by modern understanding. The researchers and engineers currently working on this are essentially pioneers exploring territory that was mapped once and then deliberately forgotten. They're not trying to recreate the past exactly. They're trying to understand principles that worked historically and adapt them for modern contexts. Maybe the solution isn't rebuilding the original planetary grid, but developing smaller-scale systems that use similar principles without the vulnerabilities of a globally interconnected network. Maybe it's hybrid approaches that combine atmospheric energy capture with modern renewable technologies. Maybe it's just understanding why the old system failed, so we can avoid similar mistakes in whatever energy systems we develop going forward. What's certain is that the knowledge won't stay buried forever. Too many people have noticed the inconsistencies. Too much physical evidence remains. Too many modern innovations are independently rediscovering principles that were functional a century ago. The information wants to be found, and it's finding its way back into consciousness through multiple pathways simultaneously. In another generation or two, the idea that 19th century architecture included functional energy harvesting systems will probably be common knowledge again, the way it was common knowledge during the system's operation. We're just living through the awkward period where it's transitional between definitely lost and rediscovered and understood. So here's my challenge to anyone watching this. Look at the buildings around you with fresh eyes. Notice the spires, domes, geometric patterns, and metalwork that official histories tell you are purely decorative. Ask yourself whether those elements might have served purposes beyond aesthetics. Look for underground spaces that seem overbuilt for their apparent function. Notice where buildings connect in ways that don't make obvious sense. Pay attention to architectural features that restoration projects always seem to remove or replace. Document what you find before it gets improved with modern materials that look similar but function differently. We're at a unique moment in history where the evidence of lost technology is still physically present but systematically misunderstood. Buildings that functioned as energy nodes still stand, even if they no longer work. Underground networks still exist, even if they're dismissed as utility tunnels. Metalwork with specific properties remains, even if conservators don't know why those properties matter. The next generation of engineers, physicists, and architects has an opportunity to study this evidence before more of it gets destroyed through well-intentioned but ignorant restoration. To understand not just what we build now, but what was built before us and why it worked differently. Whether or not we ultimately decide to revive atmospheric energy technology, Understanding it makes us smarter about energy systems generally, about architectural possibilities, about how technological knowledge can be lost and recovered. And maybe, just maybe, it makes us think twice before accepting official explanations that don't actually explain what we can see with our own eyes. The truth is out there, literally, built into the architecture all around us. We just have to remember how to read it. Thanks for sticking with me through this journey into forgotten technology and suppressed history. If this resonated with you, pun absolutely intended, hit that subscribe button and share this with someone who appreciates having their understanding of history completely upended. Drop a comment about what historical mysteries you want me to tackle next, because apparently, the past is way more interesting than what they taught us in school. Until next time, keep questioning, keep researching, and remember, just because everyone forgot something doesn't mean it never happened.